Hello, and welcome to this GIS tech video on working with MS Excel data in ArcMap and working with XY event data. The learning objectives for this lecture are to describe how to prepare MS Excel data for import into a desktop GIS tool and identify common problems, describe what XY event data in a GIS context is, and compare and contrast methods for importing Excel and XY event data into a desktop GIS tool through practical demonstration. Microsoft Excel is a commonly used digital data storage format. Microsoft Excel data can be added as non-spatial attribute tables to GIS and is commonly used for table joining. In this example, we see a spreadsheet containing urban, rural, and total population values by U.S. states. This spreadsheet also has two columns that can be used for joining or combining this data with a spatial data set that shows the outlines of U.S. states for making maps of populations. For more information on table joining, see my GIS tech video on spatial queries, table joins, and relates available on this YouTube channel. Additionally, MS Excel and other non-spatial data can store geographic data in columns as what is known as XY or event data. In a few moments, I'll talk more about XY event data. Before working with Excel data in a GIS tool, you often need to make modifications to the Excel data. These modifications include removing illegal characters, removing extra unnecessary rows, and modifying data types for joining. In the next slide, I'll walk you through some of these modifications. On this image, you can see many of the modifications that need to be done to a spreadsheet before it can be used in a GIS. For example, illegal characters such as periods and dashes in column headers. These characters will block the spreadsheet from working in GIS. Removing extra unnecessary rows. For example, these rows might not be necessary for use in GIS and will cause import problems in GIS. Finally, it might be necessary to modify data types for joining. For example, data in this column are of a numerical data type, which you can tell by the fact that they are right justified in the column. If you were to use data in this field for a join, you will need to check that the join field in the table that the spreadsheet will be joined to is of the same data type, or the join will not work. In the next part of this lesson, I'll give you a hands-on demonstration of a real-world Excel GIS data problem. In this hands-on demonstration, I'll show you how to download, clean, and import Excel data into ArcMap, and then join Excel data onto a census tracts polygon. In this demonstration, I'll use data from the American Fact Finder, which is an excellent resource for obtaining census data from the United States. To begin this hands-on demonstration, I'm going to start with the American Fact Finder webpage. And my goal here is to get data from New York State at the census tract level, and that will allow me to then join data I get from the American Fact Finder website onto census tract polygons I have in ArcMap GIS that I'll show you in just a second. To start this process, I'm going to click on the Advanced Search and click Show Me All. To begin the search, I want to first specify that I want census tracts from New York State. So to do that, I'm going to click here on Geographies and select State Census Tract, and then I'm going to select New York from the drop-down list. And I don't want a particular county as I'm looking at the entire state, so I'm going to select all census tracts within New York, and I'm going to click Add to Your Selections. And when I do that, you can see now over here that I have census tracts from New York have been in the Your Selections, and I have a bunch of different indicators that are available here. Now you can see there's an overwhelming number of possibilities, and that's why the census data is very good for doing geographic or spatial analysis, depending on what you're interested in. And for demonstration purposes, I'll just pick the first one on the top here, age and sex. So all I need to do is click on that right there and then click download. And it's going to create a zip file, and I'll click OK. And I have a pretty good internet connection where I'm doing this demonstration, so it's not taking too long to process and download. I click download, and I'm going to download this and save it to a spot where I can find it easily. And in this case, I'll use my C temp directory. So I'll save that here. And now I'm going to go and take a look at what I just downloaded, the zip file. I'm going to right click, 7-zip, unextracted here. And you can see here now I'm actually getting a couple different things. I'm getting metadata, annotation, and so forth. CSV stands for a comma separated value, and you can see by the size of the file that this is actually where most of my data is. It's almost about 4.7 megabytes. And so I'm going to open up Excel, and I'm going to browse to that C temp directory. And I have to change my file type from Excel to comma separated values. And I'm going to open up the largest one, hit open. And so here's what we got. So now the challenge here is to make this data in the spreadsheet be able to come into ArcMap and be able to do a table join. So what I first have to start doing is looking at columns. Now, GeoID is going to be a very helpful column. That's an identifier for an actual census tract. Here's even a second one with sort of less information in it. Here's the textual description of where the census tract is. And then here's my indicators or variables. So you can see there's lots of data here. Total population, margins of error, male population, female, and so forth. To make things easy for this demonstration, I'm going to only bring in total population, male population, and female population. So therefore, I'm basically just going to first get rid of all of these extra columns because I'm not really interested in them. And they probably will just cause a lot of problems when I try to bring them into ArcMap. So I'm going to highlight this column here, move my mouse over as far as it goes in terms of the rows, right click and hit delete. And that seems to have gotten rid of everything. So I should now only have, about 10 columns. Again, you only want to bring in the data that you need. So in this case, the total population will be helpful. Margin of error, I'm not really interested in. So I'm going to delete that. I'm also going to bring in, I'm going to delete, the male margin of error. And so I have the total population, the male population, and the female population. Now, if you remember from the first part of this lesson, I talked about removing illegal characters. As of it is right now, having semicolons and so forth are going to cause problem. And I also need to delete rows that I'm not interested in. So the way that I would go about doing this is the following. I know that I'm going to want either this column or that column to do the table join with. So what I'm going to do is go to this right here. I'm going to call it geo_ID and geo_. See, I got rid of the periods there. And I'll change the name of this one to just display because I might be interested in that. And I'm going to change this to just say total. So I'm looking to create really nice, clean headers, no extra characters, nothing else. Okay. All right. So that gives me a nice header row, and then I'm going to delete this second row. So now I should have a nice clean spreadsheet here with a clean header row, nothing extra that I'm not interested in, so forth. I'm actually then going to save this out of the CSV format and take it into a Excel 97 workbook or the XLS format. And I've found in my own personal experiences that this older format of Excel works better with ArcMap as opposed to XLSX. So I'm also going to change the file. I'm going to call it nypop and save that. Okay. Now sometimes it's also helpful to just close the spreadsheet in Excel when you start working with it in ArcMap. If I switch over to ArcMap now, here we see census tracts for New York, and I want to look at the attribute table here, and you can see here I have a GeoID field that hopefully will work as my join column. So let's try that out. So I go over to Catalog, and I'm going to go to my ctemp directory where I downloaded the data. And here's that new spreadsheet, New York Pop. I expand that out. I just have one sheet in there. I'm going to drag that over. So far, so good. I'm going to right-click on the sheet to make sure it's working correctly and do Open. And so far, looking good. So again, nice clean columns. Everything seems to be showing up well. I've got about 5,000 records. And now I'm going to look a little closer at my fields to make sure I can do the join correctly. So when I right-click back on the census tract attribute table, I get this table, and you can take that table, hold your left button down, and kind of dock it using that button to compare the two. It looks like in this case, the field GeoID 10 over in New York census tracts is the same value as geo_ID 2 over in the census data. Now, one important thing to note here is that these are actually different data types. If you look at GeoID 10 over in the New York census tracts, it's actually a text data type that you can tell by the fact that the characters are left justified. And over in the census data, the data values are actually numerical because they're right justified. This actually creates a good opportunity for learning how to troubleshoot problems with Excel data. I'll be very clear and upfront with you that it is in fact very difficult to work with Excel data in ArcMap. There can be a lot of problems with trying to convert data types, and the fact that ArcMap does not read Excel tables natively and so forth. So I'm going to show you one solution to this problem. It may not be the best solution or the only solution, and if you're watching this video and you care to provide comments on a better way to solve this problem, I welcome them. I'll show you how I'll go about fixing this. So our problem here is that we have different data types in these two tables, and we need the census data to actually become a text or string data to enable the join. Now the first thing we might try to do is go back to Excel and change the data type around, so to make this numerical data in the spreadsheet equivalent to string data. So let's see what that might look like. So I'm going to close this table, and I'm going to go back over to my spreadsheet. And when I open that up, you can see that all of these numbers are right justified, indicating they're numerical data. So I'll click on the column heading, right click, do format cells, and change them all to text. And that changes the number so they're now left justified as text. I'll save, close this, close Excel, and I'll even, just to be thorough, I'll remove the table out of ArcMap, go back to Catalog, I'll refresh the temp directory, and I'll bring the table back in. Now when I go to look at the table, presumably with my data changed, you can still see that even though I changed the data type in Excel, it's still showing up as a number. And I did a lot of research on this problem, and there doesn't seem to be any way you can specifically tell ArcMap to bring characters as numbers in as text. From the documentation, ArcMap is going to look at the first 8 rows of a data set to determine the kind of data that it is. So let me show you one trick that I would do to solve this problem. I'm actually going to take this data out of the Excel format and go sort of back in time to an old-fashioned DBF file that ArcMap can read. And then I'm going to use the field calculator to do a cast. So let's show you how that would work. So I'm going to close this table. I'm going to go to this Excel table. I'm going to right-click and do Data, Export. And I'm going to export all the records. And I'm going to put it in my ctemp directory. And you do a file pick doing that. And make sure you select type as DBase table. And I'm going to call it Census New York as a DBase. Save that. And let that run. And I'm going to add it back to the map. So I've now physically taken the records from the spreadsheet and put them into a new file. And if we go back over to the temp directory, you can see now there's a Census New York DBF. And the reason I'm doing that is because I can now make edits on this table. You cannot make edits directly to an Excel table. They're brought into ArcMap as read only. But now with the DBF table, which ArcMap can read and edit natively, I'm going to open up this table and I'm going to create a new field in this table by going Add Field, and I'm going to call it GeoIDTXT. And the key thing here is I'm going to make the data type text, and you'll see why that's important in just a second. So I'm going to hit OK, and you can see I have a new field now got created. Now, if you weren't aware of this feature in ArcMap, there's something called the field calculator that allows you to do edits directly on a field. So the way that would work is I'm going to click on this column heading of my new field and click Field Calculator. And yes, I'm going to just hit yes to the warning that I can continue. And basically in this dialog, I'm telling it that I want to make the value of the GeoID text field equal to the value of the GeoID2 field. And what that's called in programming terms is a cast, meaning you're taking data from one data format, such as a number, and casting it into a string. And so I'll hit OK and let that run. And you can see it happened pretty quickly, but notice now all of my records that were numerical in GeoID2 have been cast over and are now text strings over in this new column. And that'll enable me to now do my join, which was my final goal. Okay, now to reach my final goal of doing the join, I'm going to right-click on the census tracts, select Joins and Relates, Join, and the field I'm going to use for this is the GeoID 10 field, and the table I want to select is my new DBF table, Census New York, and the field I'm going to base this on is my new text field that I created. I'm going to select Keep Only Matching Records, and then I'm going to hit Validate Join, and I'll just ignore that for the demonstration. And you can see here that 4,906 of 4,919 records matched, which is pretty good given the problems that can happen with table data. Now this is something you would have to follow up on and try to figure out why some of the records are not joining. I'll hit close there, I'll hit OK, and I'll hit no to that. And now if I take a look at my attribute table of the census tracts, you can see that the data from the census has now been added to my census tract polygons, and what I was really interested in were these numerical values by population. And so now I can create a simple map showing those population values as a thematic map. So Excel can be an important format for bringing external numerical data or other data into ArcMap. However, just be aware that it can be very problematic, and if you like working with data, it can actually be a fun exercise in being creative with ways to deal with the various problems that come with Excel data. As you saw in my example with exporting the Excel sheet into DBF and then casting numerical data into text data that allowed me to join to my census tract polygons. XY event data is the idea of geographical references being stored in the columns of a non-spatial table. XY in this case is referring to an XY Cartesian grid. More specifically, The X column contains the longitude or easting value, and the Y column contains the latitude or northing value. In this image, you can see an example of a spreadsheet that contains XY data. Specifically, the column block X chord contains the X coordinate, and the column block Y chord contains the Y coordinate. When the data from these two columns are processed in GIS software, the GIS software will render a point feature at the combined XY location of these coordinates. In the next part of this lesson, I will give you a hands-on demonstration of working with XY data in a GIS tool. In this hands-on demonstration, I will show you a real-world XY event data scenario. Specifically, I'll show you how to download and clean XY data, and how to import XY data into ArcMap. I'll use data from the GeoNames data dump service. GeoNames contains freely accessible place name references from around the world that are stored as XY data. In this demonstration, I'll show you how to download data that has XY event data in it, which you can use then to render the XY data as point features in ArcMap. And what you're looking at now is the GeoNames data dump web page. And what I'm interested in here is going to their download server. And for this demonstration, I'm going to download place names from the country of Poland, but you can download really any country that you're interested in here. So I'm going to scroll through their list and look for the country code of Poland, which is PL. And that's going to be right here. And so it's real straightforward, a zip file. I'm going to actually right click and do a save link as. And I'm going to save it into a convenient spot where I can get back to it. So that comes like that. And here we see this pl.zip, so I'm going to unzip that out. And basically what you're getting is a giant text file. And similar to what you saw earlier in this lesson, you can use Microsoft Excel for working with data like this. So I'm going to copy that directory, open Excel, and open that text file up. And that's why I copied the directories, I can get to it quickly. And you need to change your type down here to text file. I'm going to open that. And you're going to get the import dialog in Excel here. And this is what's called a tab delimited file, meaning a tab separates each column. So you can see by default it selects tab, and you can already see the columns starting to form out. So I'll work my way through this. And I'll finish that. And take a look at what we've got here. Now the key things are, we're looking for those X and Y columns that'll give us latitude and longitude of places we're interested in. And one thing about this particular data set, it doesn't come with a header in terms of what the actual rows are. So in this case, I've kind of used my intuition to look at that, and I know that these are going to be decimal degree latitude longitude columns. Another thing you can do too is if you go back to the GeoNames service and you look at the README file for text info, it'll tell you what all the header names are. And this is kind of a form of metadata that I do have another video on GIS metadata, so that's why this is really important. So the main GeoNames table has the following fields, and if we even just put this README file sort of next to the data itself at the first row, you can kind of see the GeoName ID, the name of the place, alternative names, and this is right here, the latitude and longitude. So what I'm going to do is actually go in my spreadsheet, create a new row, and also give some header names. And for demonstration purposes, I'll just use a few columns. So I'll actually delete other things I'm not really interested in. So I'll delete that, delete that. But I am interested in the latitude and longitude. So latitude in decimal degrees, longitude in decimal degrees, WGS 84 datum. So much like you saw when I worked with Excel, I'm using very straightforward, simple headers. And for your own reference, you may be interested in things like feature class and feature codes. Those tell you what these places are. Are they a populated place? Are they a natural feature? And so forth. But for demonstration purposes, I'm going to then delete out all these other columns. So I have myself a really nice, clean data set here. And I'm going to then just save it. And that's okay. I'll hit yes there. Because I'm looking for, again, a really straightforward, clear data set. All I'm really interested in are these XY values of latitude and longitude. Close that. Close Excel. Now if I go over to ArcMap, I have here some administrative boundaries from Poland ready to go to try this data set out. And I'm going to add the XY data just like I did the Excel data that you saw earlier in this demonstration. If I go and refresh my directory, you can see now I have the PL text file that we just did some modifications on. I'm going to drag and drop that over. And then I'm going to right click and check to make sure that it looks okay. And looking really good here. I've got an identifier, a name, and my XY data, also known as the latitude and longitude. Now to actually render the XY data, it's pretty easy. All you do is you right click on your file, and right here it's even got a way to go right into displaying XY data, or what they also call events. And it's helpful to sometimes use terms that ArcMap might recognize, like long for longitude or lat for latitude, because you can see that the X field already knows that it should be going for the long and the Y should be going for the lat, and it even knew to use GCS WGS as the coordinate system. So when I hit OK, and I'll just don't worry about that for now. And now you see all of these many purple dots that have just appeared on Poland, but that's actually very good. That means that this XY data is showing up where it should. And if we zoom in a little closer, we can see that this is actually a very rich data set in terms of place name references all across this particular country. And I do recommend GeoNames if you're looking for place names or toponyms for any country in the world. Now, one last thing just to show you, that ArcMap actually creates XY data as a temporary sort of events file. So if you want to actually take the data out and save it as a permanent feature class, you can use a technique that I showed you earlier where you go and right click and select Data, Export Data. And I'll just use the defaults for demonstration, ctemp, export output. I might change it based on what I want. I'll just do a shapefile to be convenient here, and I hit OK. Now it's taking that event data, which is like sort of temporary in memory, and writing it out to a brand new file on disk. And there's about 56,000 records here. But the key thing is now it's written out as a permanent feature class, and it's no longer just a temporary file based on the event data, allowing me to do a lot more with it than simply keeping it in sort of in memory as an event. In this lecture, you learned how to prepare MS Excel data for import into a GIS desktop tool by identifying common problems. For example, illegal characters that might prevent data from being imported, extra rows, and changing data types so the data can be joined. You also learned what XY event data is in a GIS context. XY data is the idea of geographical references being stored in the columns of a non-spatial table. Finally, You learned how to compare and contrast methods for importing Excel and XY event data into a GIS desktop tool through practical demonstration. Specifically, I showed you how to download and import data from the American Fact Finder service and how to download XY data from the GeoName service. I hope these examples would give you some confidence in working with your own Excel and/or XY data in GIS. The following are references used in preparing this lecture. If you enjoyed this GIS tech video or have any comments or questions, feel free to contact me at the email address below. Thank you for watching.